All right, 5-4, medians and altitudes. Objective of this video, to identify properties of medians and altitudes of a triangle. All right, so here's your vocab. Vocab word number one, median of a triangle, which is a segment whose endpoints are a vertex and the midpoint of the opposite side. So if you look at my triangle I have down here, line AD is a median of the triangle because it goes from vertex A to the midpoint of line CB. We know it's the midpoint because CD is marked congruent to DB. So that's how we know it's the midpoint. So therefore AD is a median. I'm going to write that up here. Line AD is a median of this triangle. Second vocab word, centroid of a triangle, which is the point of concurrency of the median. So it's the point where they all three cross. This is also known as the center of gravity for the triangle. So if you were to cut out a triangle, determine the centroid, you could actually balance the triangle on your pencil, like the eraser. Okay, you could actually balance it on the eraser of your pencil if you placed the centroid on your eraser. Okay, altitude of a triangle. It's the perpendicular segment from a vertex to a line containing the opposite side. The reason it's worded as a line containing the opposite side, I'll get to this more in a few more slides, but if you have an obtuse triangle, your altitude can actually be outside of your triangle. Okay, so you'd have to extend the line. I'll show you more about that later. But in our diagram here, line CF is an altitude because it goes from the vertex C perpendicular to side AB. All right, it doesn't have to hit in the midpoint. It may. It doesn't have to hit in the midpoint. It doesn't have to hit anywhere in particular along the other side. And in an obtuse triangle, you'll see in a minute, it doesn't even touch the opposite side. Okay, so just write that down. And I'll explain that a little more in a minute. I think it'll make more sense if it's confusing now. Last word, orthocenter of a triangle. The point of concurrency of the altitudes of a triangle. So it's where the altitudes cross. Okay? Make sure you write all these words down, and I would draw the picture too. All right, concurrency of the medians theorem. Only reason I wanted to show you this was because of this. The medians have a special property, okay? A line from the vertex to, what is this called again? It's the centroid, is actually 2 times longer than from the centroid to the side of the triangle. So if this was 8, this would be 4, okay? Now I know this says DC is 2/3 of DJ. The reason they tell you that, because if they told you that DJ was 12 and asked you for DC, what you could do is multiply that 12 by the 2/3 to be able to come up with the 8, okay? The 12 and the 3 would cancel. That'd go to a 1. That'd go to a 4. So that would be 8, okay? So if you're given the whole thing, DC is 2/3 of the whole thing, and CJ is 1/3 of the whole thing, okay? It's 1/3 of the whole thing. You do the same thing. You could do 12 times 1/3. That would cancel with that. That'd go to a 1. That'd still go to a 4. 4 times 1 is 4. And of course, 8 and 4 is 12. Okay? So that's the important thing to take away from the medians of the triangle. Is the segment of the median that is from the vertex to the centroid is 2/3 of the total distance and is twice as long as the part from the centroid to the opposite side. Okay? So like if FC here was 10, CH would be 5, and if this was 12, this would be 6. Okay? But like I said, that's the important thing to take away from medians of a triangle. All right, let's keep going. So here's another example of what I just showed you. It says in the diagram at the right, XA equals 8, and it wants to know the length of xb. So it wants to know this whole length here, okay? Well, you can set it up this way. We know that xa equals 2/3 of xb. So we know that 8 is 2/3 times xb. So now you can multiply both sides by the reciprocal, like they did. The reciprocal of 2/3 is 3/2. Okay. 8 times 3/2 is 12. So xb equals 12. Okay. That is one way to do it. But like I said, the important thing to remember is that the median, the part of the median from the vertex to the centroid, is 2/3 of the entire length of the median, and it's also twice the length from the centroid to the opposite side. Okay, so what would AB be right here in this case? You said 4, you're correct. It would actually be 4. All right, so I want you to do these two little got it questions real quick. You know what, don't do B, just do A. Yeah, so do 1A real quick and we'll go over it. All right, it says in the diagram for problem 1, ZA equals 9. And then it says, what is the length of ZC? All right, so we know that ZA equals 2/3 times ZC, right? So we know that 9 equals 2/3 times ZC. Multiply both sides by the reciprocal. All right, because that gets rid of that. So ZC equals 9 times 3, which is 27 over 2. Okay, it's 27 over 2. Or if you divide that out, you get 13.5. And you can verify that because you know that ZA is twice the length of AC. So half of 9 is 4.5. 4.5 and 9 is in fact 13.5. It checks out. All right. And the reason I didn't have you do B is because it says what is the ratio from ZA to ZC to AC. Remember, this is 2/3 of the line and this is 1/3 of the length of the line. Okay. So if you were to divide this by 3, you should get 4.5. All right. So now let's move on to altitudes. Remember how I said that the altitude goes from the vertex to a line containing the opposite side? Well, here is a picture of that right here with this obtuse triangle. As you can see, from this vertex down to this side, if you draw a perpendicular line, you are not going to touch this side at all. But if you extend this side out, okay, if you extend this side out, that's what this dotted line here is for. If you extend this line out, you can bring an altitude down. So then therefore, this is an altitude for this obtuse triangle. Okay, and as you can see, it happens again here from this vertex. Okay, they had to bring one down. So just remember, just like the circumcenter, the orthocenter, it can be outside of the triangle. Okay, like this is the orthocenter for this obtuse triangle. Now a right triangle, the orthocenter will be on the triangle and it'll be at the 90-degree angle. Okay, that'll be the orthocenter for a right triangle. Because if you draw a perpendicular line from this vertex down, since this is a right triangle, it's going to follow that side. Same thing here. If you drew an altitude from this vertex, it would follow this side. And then of course, the altitude starting at this vertex would go perpendicular to this side. Okay, so a right triangle, the orthocenter is going to be right there. Obtuse is going to be outside. And acute, it's going to be inside. Okay. So again, it's the same thing. It's just a perpendicular line from your vertex to the opposite side of your triangle. All right, vertex, opposite side, vertex, opposite side. And remember, there's no special place that it's going to meet the opposite side. The only thing that you need to know is it has to be perpendicular to the opposite side. So if it happens to bisect it, wonderful. If not, it's still an altitude. Okay? Other than that, there's really nothing special about altitudes. There's no ratio that says, oh, this part is this long and this part is this long. Okay? There's nothing special about them except they go from a vertex perpendicular to the opposite side. Okay? And here's kind of a review. I know we've gone over a lot of different centers, so to speak, of triangles. Here's kind of a chart that wraps all four of them up together. Our perpendicular bisectors, remember, is the circumcenter. So that goes perpendicular from the midpoint of one side through the triangle. So all of these segments here are congruent, and that's your circumcenter. Your incenter are your angle bisectors. Your centroid is formed by your medians, and your your orthocenter is formed by your altitudes. I would recommend writing this chart down and committing this to memory. Okay, so 4 different ways, 4 different centers. All right, so now let's kind of wrap this up. Here's your ticket in the door. Number 1, is AP a median or an altitude? If AP is 18, what is KP? If BK is 15, what is KQ? Which 2 segments are altitudes? Number 5, your classmate says she drew HJ as an altitude of triangle ABC. What error did she make? Number 6, does it matter which 2 altitudes you use to locate the orthocenter of your triangle? Explain. And number 7, the orthocenter of triangle ABC lies at vertex A. What can you conclude about line BA and AC? Explain. I will tell you this goes back to that theorem about the medians that I showed you at the beginning of the video. All right, so good luck on that. Make sure you complete these before you come to class tomorrow.